Okay, welcome back. I'm going to discuss about a normal distribution question related to the statistics paper 1. Here they say that the shortest time recorded by an athlete in a 400-meter race is called as their personal best, and this is normally distributed with a mean of 49.2 seconds and a standard deviation of 2.8 seconds. So they want you to find the probability that this personal best lies between 46 and 53 seconds, and then they say to find the t value so that 92% of athletes from this club has exceeded this t value. So and then they talk about some kind of a tree diagram problem related to this, which has three talks about three athletes. So let's go by part. So in section 1, here's the question, and in section 1 we could define x first. X is normally distributed with 49.2 and 2.8 square, and we want to find that x lies between 46 and 53. X lies between 46 and 53. So first thing what you need to do is normalize this. So I would subtract each term in my inequality by the mean and divide it by the standard deviation. So it becomes 46 minus 49.2 over 2.8 less than z less than 53 minus 49.2 over 2.8. So let's get the numerical values of these three. So this becomes it's minus 8 by 7. This is minus 8 by 7 less than z less than, it's gonna be plus 19 by 4. Plus 19 by 4, so to get it into decimals, so this is basically 1.14 minus 1.14 less than is it less than, it's going to be 19 over 14, and that is 1.36. So here are the two values that this lies between. So I can make it is it less than 1.36 minus is it less than minus 1.14. So now this one is it less than 1.36. This is somewhere here. 1.36 is in the second half, and the area considered to be is shaded by from left to 1.36. We talk about this whole area. Minus is it less than minus 1.14 needs to be considered from the left side, which is a negative value. So this is a tiny little area. So I can go further. So is it less than 1.36 in my normal table? I'm using the one endorsed by the Pearson's formula booklet. 1.36, it gives me 0.9131 minus. So now this part is a bit trickier because you cannot find a negative z value from the normal distribution. So this area shaded over here is same as this area over here with 1.14, and that area is equal to 1 minus probability of z less than 1.14. So this is something which we need to transform. 9131 minus 1 plus z less than 1.14. So 1.14 from the normal table is 8729. So it's basically this. So this should add up to 9131 minus 1 plus 8729. So this should add up to 0.786. So that should be the answer for the first part, where it lies between 46 and 53 seconds. Right. So moving on to part 2, they talk about finding the value of t for which 92% of athletes from this club have more than t seconds. So probability of x greater than t should be equal to 0.992. So if I illustrate this using a normal distribution diagram, so let's say this is our t value. So this part should be 0.08, whereas the rest becomes 92%. So let me normalize this first. This becomes z greater than t minus 49.2 over my standard deviation is 2.8. So here is 2.8. So here is my z value. So this gives rise to t minus 49.2 over 2.8. So you know the normal distribution is always symmetrical about the mean. Therefore, if this gives a probability less than 0.08, somewhere over here should replicate the same with the mirror image of this one, which is 49.2 minus t over 2.8. So I could say probability of z less than 49.2 minus t over 2.8 is also equal to 0.92, because the probability greater than this value over here is 0.08. So less than that value should be 0.92. So 0.9200 from my normal table, I cannot find an exact value, but the closest I could find is 1.40. So I could say 49.2. All right, let me mention that as well. So probability of z less than 1.40 is equal to 0.919. So that is 0.92 approximately. Therefore, now we could say 49.2 minus t over 2.8 is equal to 1.40. So you can find t. 49.2 minus 2.8 into 1.40 should be equal to t, which gives you a value of t which is 45.3 seconds, correct to one decimal place. I haven't mentioned, so I'm leaving it for 3SF. 45.3 seconds should be the value, whereas 92% of personal best of these athletes exceeds this value. All right, so next they say 3 athletes from the club are chosen at random. Find the probability that exactly 2 have personal bests of less than 46 seconds. So let's find the probability of it being less than 46 seconds first. So I think we simply found that over here. It was found over here. This probability talks about z being less than 1.14, which is the z value for 46 seconds. So that is 1 minus 0.8729. So let me start with that. Probability of x less than 46 is 1 minus 0.8729. So this is 0.1271. This is the probability. So now you pick 3 athletes and they want exactly 2 have personal best less than 46. So let me define this variable as s for our own understanding. You can say an athlete has a personal best. They say that it is less than 46. All right, so we want exactly 2 of the 3 athletes to have a less than 46. So it should be probability of s dash, or else what this means is the first 2 athletes tend to have less than 46 and the third person doesn't, and this combination can have 3 occurrings. So it could be s dash s, or else it could be s dash s and s. So it's kind of a tree diagram. So this probably is 1.2711. It should be 3 times 1271 into 0.1271 into 0.8729. So this should be the final answer. So let us check this one. that's gonna be so this gives you 0.0423 as the answer. So that's it. That's the whole question. So let me go back again. So they say exactly 2, so this is that probability where it has exactly 2. All right, thank you.